All right, guys. Questions on the homework before we get started? Questions on anything, any of the homework assignments up to this point?
I have a question just to be sure. So on 7.1, if it's like y equals x plus 4 is automatically either.
Yes. Yeah, y equals x plus 4, x minus 4. If we have addition or subtraction, it's not going to be inverse or direct. Yes, because with direct and inverse variation, the main forms for direct, y equals a times x. We're looking for this constant term a, any number, that we're multiplying x by to get to the next y value. So the y values and x values are increasing by that same constant amount. Now, inverse, a divided by x. So again, we have this constant amount that's being multiplied or divided to go from term to term. So addition is not having that same constant rate, that same constant amount we're multiplying or dividing by, so it doesn't follow either. That also means that quadratics, x squared terms, aren't direct or inverse because they don't have that same amount. Our square roots, our radicals, any other function that doesn't match this, just pure multiplication or division, is also going to be thrown out. Does that make sense? Okay. Trying to remember where we stopped yesterday. I think that one there. The x2 over x minus 4. Right here. Did we finish this one? Okay. So, let's look at this one here. I think, yeah, you were saying we started this one? Okay. So, first thing we need to look for, all right, guys, yeah, up here. So, first thing we're looking for is something to multiply the top and bottom of this fraction by to get the fractions on top and bottom to simplify. So, as we look at this here, the fraction on top, the only one we have is 2 over x. And if we're able to multiply that by x, it's going to get that fraction simplified. So I have to do x on top and bottom. The only other fraction on bottom of this fraction is the 2 over x, which again, that 1x will simplify it out. And so the next thing we need to do is distribute, multiply through. Our 2 over x times x is going to be 2x over x minus, and our 4 times x is going to be 4x. Now, we're not so much concerned about the 4 with our multiplication because it does not have a denominator. It's not a fraction. It's not a fraction. Now, at this point here, we're going to do the same thing in the denominator, the bottom of the fraction. 2 over x times x is going to be 2x over x plus 3 times x is 3x. Now, at this point here, we can simplify. Because 2x over x, since we have a product on top, the x and x will simplify, leaving us with 2 minus 4x. On bottom, the x and x will cancel, leaving us with 2 plus 3x. Questions on this so far? Now, the denominator 2 plus 3x, the degree is 1. 2 and 3 don't have a common factor, so that is as simplified as it gets. However, if we look on top, 2 minus 4x, there is a greatest common factor of 2. And if we factor 2 out of 2, divided by 2, we get 1. We factor the 2 out of negative 4x, we get negative 2. So that does simplify. We can reduce the numerator by factoring that 2 out. Then again, we can check top and bottom, but even though we do have this 2 outside and a 2 on bottom, that 2 and the 3x are stuck together because of addition. telling us that 2 times 1 minus 2x all over 2 plus 3x is the final answer. Even though factoring the numerator didn't affect the total sum or didn't affect any kind of reduction, we can leave it as this here. If you wanted to rewrite it in standard form, we could. It's leaving it as the form we had is perfectly fine as well, but this would be in standard form. You don't have to write it this way. These are equivalent statements. Yes? Mm-hmm. Okay. Three over x plus 5 all over 2 over x minus 3 plus 1 over x plus 5. Again, we need to look at the 3 denominators, the 1 on top and the 2 on bottom, to see what we need to multiply everything by to get the fractions to simplify out, so that we don't have fractions on top and bottom. What is one of the expressions we can multiply everything by? X minus 3, yes. Because the x minus 3, the one of them on bottom will cancel with 1x minus 3. What else do we need? Yes, we need an x plus 5. Do I need 2 of them? Because it shows up in 2 spots, doesn't it? Because we have one of the x plus 5s in the denominator on top, and one of the fractions on bottom has x plus 5 in the denominator on bottom, yes? How many times does it show up in each of those spots? Once, yes? So do we need it twice? No. It does show up in 2 different places, but each time it shows up, it only shows up once. Now what we can do is multiply these out. So on top, the x minus 3 times x plus 5 is going to multiply with the fraction on top's numerator, the top fractions, top part, giving us 3 times x minus 3 times x plus 5. And it's over x plus 5. We're going to do the same thing with the denominator. So we're going to multiply the 2 on bottom by x minus 3 and x plus 5 all over x minus 3 plus. We're going to do the same thing with 1. Well, 1 times x minus 3 times x minus 5 is just x minus 3 times x plus 5 over x plus 5. Questions on this so far? Now we need to simplify. If we look at the numerator, the fraction in the numerator is x plus 5 over x plus 5 will cancel out. They'll simplify, leaving us with 3 times x minus 3. On bottom, in the first fraction, x minus 3 and x minus 3 will cancel, leaving us with 2 times x plus 5. Plus, in the last fraction, the x plus 5 and x plus 5 will cancel, leaving us with x minus 3. Questions on this here? As a side note, if we did this multiplication, we did the reduction that we just did, and we see that a term didn't cancel, is there anything saying or anything preventing me from going back up here and realizing, oh, I need an extra x minus 2 because it didn't reduce in one of the fractions? It's not in this one. But is there anything saying I can't go back and add a product at the start? Well, no, because I realized I missed a term. We can add it back in all the corresponding places like we just did, and that is a terrible 2. Simplify where needed and go from there, yes? Because there's nothing preventing us from that. It's almost better to multiply through with what we think it is and realize I missed a term than to have too many. Because if there's too many, they're going to simplify out, and the leftover is just going to stay where it is. But that's just a side note. Questions on how we got here? Let's look at the denominator first. I have 2 sets of parentheses being added. There's a good chance there's like terms we're going to have to add or subtract. So it's going to be helpful for us to multiply through by the 2. 2 times x is 2x. 2 times 5 is plus 10. Our x minus 3 is, well, going to stay plus x minus 3. Because we're distributing a positive 1 through it. The signs aren't changing. We still get this here. And we do see at this point, we do have 2x and x that are going to combine. We have 10 and negative 3. They're going to have to combine. And then we're going to have to do what at the end? We're going to have to factor. See if there's a greatest common factor or different ways we can factor. Yeah. All right. We skipped over the numerator. So at the top of the fraction is what? 3 times x minus 3. So we can do the product, yes? But is there any other like terms on top that we're going to need to add to it? Do we have multiple x's? Do we have multiple numbers? Because we could do this and say 3x minus 3 and get here. There's nothing wrong with that. And then we could move on and add our like terms. 2x plus x is 3x. 10 minus 3 is positive 7. Telling us that we have 3x minus 3 over 3x plus 7. Yes. Do we have any other like terms on top? Do we have any like terms on bottom? They would, but unfortunately, because there is a plus and minus, minus on top, plus on bottom, they're stuck together as a single term. Yeah, because otherwise, if it was 3x times instead of minus, and 3x times, if this was a product, instead of addition, subtracting, yes, the 3x over 3x would cancel. But unfortunately, the minus on top and the plus on bottom prevent us from being able to just cancel those out. That's a good question. Any other questions? But yes, at this point, we do need to start looking at simplifying, yes? So the first thing we have to look for simplifying is seeing if there's a greatest common factor or ways to factor the top and bottom. Well, wait. The numerator 3x minus 3 has the greatest common factor of almost, not x, but 3 that we can factor out so that we can see if something simplifies on the top with the bottom. So that does factor out. 3x plus 7, 3 and 7 don't have a common factor between them. They both don't have a variable, so it stays 3x plus 7. Questions on this here? Does anybody see the redundant step? Because I think I miswrote the top. I did. Because that's 3x plus 3. 3. What should that have been? This should not have been 3. This should have been, what? 9. 9, and that is 3. I'm glad I looked back at that. But the top, that we had 3 times x minus 3. We distributed the 3. There were no other like terms to combine with the 3x or 9. So when we went to simplify at the end, we factored the 3 right back out and got back where we were. But either way, we still get to the same answer. Questions on this here? All right. We're going to look at 2 more, and then we will be done with 7.42. When we look at this problem here, again, the first thing we really need to do is figure out what we need to multiply the whole thing by. So that the fractions on top are 1 over a and 3 over a minus 2. And the 2 fractions on bottom, the 2 over a and 5 over a minus 2, those fractions will simplify down. We won't have fractions there anymore. And to do that, we need to figure out what we need to multiply everything by. So what's one of the things we can multiply everything by? A. Because by multiplying a, it is going to simplify this 1 over a and 2 over a. The a on bottom of those will simplify out. Since a only shows up 1 time in each of those 2 fractions, we only need it once. Anything else? A minus 2. Now at this point here, we just need to multiply these out. And we multiply in the numerator. This a times a minus 2, we're going to multiply it with the 1. And we get 1 times a minus 2, which is the same as just a times a minus 2. And it's all over a minus. We're going to do the same thing, a times a minus 2 with our 3, which will give us 3a times a minus 2 over a minus 2. Now we're going to do the exact same thing on the bottom of the fraction. So we're going to start off with multiplying 2 over a, so the 2 by a times our a minus 2 all over a plus. Then we're going to multiply the a times a minus 2 with 5. Gives us 5a times a minus 2 over a minus 2. Questions on this here? Now we need to simplify. So in the numerator, since we have that a times a minus 2, we have this product. That product of the a times a minus 2 lets us simplify that a and a, leaving us with a minus 2 minus. Here the a minus 2 and a minus 2 will simplify, leaving us with 3a. So the numerator is our a minus 2 minus our 3a. On bottom, since we have 2a times our a minus 2, since that 1a is outside, it's being multiplied by that other quantity, it will reduce, leaving us with 2 times a minus 2 plus. In our last fraction, the a minus 2 and a minus 2 will cancel, leaving us with 5a. Questions on how we got to this point here? Now, the next thing I'd look at is, because we're going to need to simplify as far as possible and then check and see if there's anything that simplifies on top and bottom. As we look at the top, I do have multiple terms showing up. Unlike the last one where we had a number times an expression, then we had nothing else. So there's going to be most likely, or there's probably going to be some like terms that are going to have to be combined. So we do need to simplify that. And for our a minus 2, we can drop the parentheses and it's still a minus 2. Our minus 3a is going to be negative 3a. Since there's just that single term, we just get this here. On bottom, our 2 times a minus 2, we're going to have to distribute this 2. 2 times a is 2a. 2 times negative 2 is negative 4. And then we're adding 5a to it. Just move that over. Last thing we need to do is combine like terms and check and see if anything simplifies. Our a minus 3a, 1 minus 3, would be negative 2a. And we still have our negative 2. On bottom, the only like terms we have are 2a and 5a. Well, 2a plus 5a is 7a. And we have 7a minus 4. Now we can say this is finished, this is simplified, as long as nothing will factor or reduce. 7a minus 4, 7 and 4. There's nothing that goes into both of those. There is no common factor between these two. Negative 2a minus 2. Is there a greatest common factor between those two terms? There is. It's not going to actually reduce with anything. But they actually have a common factor of, they both have negative 2. Now you can take out the negative 2 or just 2. If we take out negative 2, it's going to turn the negative 2a into positive a, because negative 2 divided by negative 2 is positive 1. Negative 2 divided by negative 2 is positive 1 also, giving us this here. You could have chosen not to take the negative out, which would give us an equivalent statement. It's just that the a and 1 inside the parentheses would be negative instead of positive. Now, unfortunately, the 2 out front, the 2 we factored out, will not reduce with anything on bottom, because 7a minus 4, again, is a single expression, doesn't match anything on top. If we had 2, 4, an even number in front of that 7a minus 4, in front of those parentheses, then the 2 on top and that number on bottom would reduce. Questions on this here? We're going to do one more, and then we will be finished with the note sheet for today. Last one we're going to look at is this one here. Now this one here, and the reason I'm doing this one last, it has one key piece that the rest have not had up to this point. And it's mainly with that 8x minus 20. Because our gut reaction, especially at this point here, is to go, we know we need 2x minus 5 for sure. Because one of the fractions on top has 2x minus 5, one of the fractions on bottom has 2x minus 5, so we multiply by it. But we also have the 8x minus 20, we would multiply everything by also. However, 8x minus 20, this is the first expression we've had that is factorable. Is there a number, a greatest common factor, between 8 and 20? 4, yes? So let's see what happens. Because if I factor a 4 out of 8x, 8 divided by 4 is 2, we still have our x. Minus, I factor the 4 out of 20, we get so really 8x minus 20 is just 4 times 2x minus 5. So again, multiplying it by 2x minus 5 and 8x minus 20 would eventually get us to the same result. But what we'd actually been multiplying by is, if I did 8x minus 20 here, really what we're saying we're multiplying it by is 4 times 2x minus 5. Which is fine, we'd still get to the same answer, but we're multiplying by 2 of them when we only really need 1. So we don't need that, because really what we need to multiply this by is, we still need the 2x minus 5 on top and bottom, but the only other thing we need is what? 4. So the reason I'm pointing this out, and especially with this one here, if the denominators are factorable, factor them and see what we get. It might not make a difference, but here, not factoring it would have added an extra 2x minus 5, making our numbers, making our equations a lot bigger than they needed to be. Now, up to this point, we haven't had it, but especially as we move forward into solving and doing other simplifying, factoring it as far as possible and then starting our steps is going to be key. Because as we multiply this through, on top, our first fraction, our 1 times 4 times 2x minus 5 is, well, 4 times 2x minus 5 over 2x minus 5. Minus 7 times 4 times 2x minus 5 over 4 times 2x minus 5. Questions on how we multiply through the top? Now we just need to do it with the denominator, our 4 times x times 2x minus 5 over 2x minus 5. Gets us to this point here. Questions before we start simplifying? In the top fraction, the 2x minus 5 and 2x minus 5 would cancel. On the fraction on bottom, the 2x minus 5 and the 2x minus 5 would cancel. Now, I avoided that other fraction on top specifically because, for the most part up to this point, and most likely your first assumption would not have been to just say 4 times 7. Because we're multiplying those two numbers, probably your first instinct is just to say it's 28, because we're going to multiply those together, yes? But when we simplify at this point, 2x minus 5 and 2x minus 5 would reduce 28 over 4 has something in common. 28 over 4 is going to reduce to what? So it's going to reduce to 7 either way, yes? Because I notice, or if you notice that, well, I'm going to back it up, that when we reduce here, yes, 2x minus 5, 2x minus 5. Oh, 4 and 4, they're going to reduce out anyways. There's not a whole lot of reason to multiply them through. Now, we did that with the 4 and x. 4 times x is 4x. Or if we left it as a non-multiplied form, really the only difference is that we don't have the multiplication sign between 4 and x. So putting them together and writing it as 28, we do get back to 7, or leaving it as 7 times 4. 4 over 4 reduces, telling us that it's still 7. Does that make sense? Our first fraction is 4. And the denominator is 4x. I think we can reduce the numerator a little bit, yes? 4 minus 7 is negative 3. The denominator is 4x. Negative 3 and 4 don't have any like terms, so we can't simplify, we can't reduce there. We could if they did, because there is no addition or subtraction on top at this point, none on bottom. We don't have terms that any of the addition or subtraction to mess with this here. But this is as simplified as it gets. Negative 3 over 4x. Questions on this here? And that is it for 742.